Hey guys, this is Mrs. Allgood, and this is the first of several reviews for you. I'm going to try and do a review on a particular topic. You don't have a packet for this. This is just something that you might want to write down on loose leaf as we talk about it. That's totally up to you. Of course, you do have notes on properties of water, but it's up to you how you learn from this. And then I'm going to try to attach like an FRQ and then maybe some short multiple choice on it, just to make sure that you've grasped what we're trying to review that day. I know you have lots of papers left. You have some Kingdom Animalia stuff. You've got some body system stuff. Right now, I'm not planning on doing that. I think our time would be best served reviewing because body systems are not supposed to be on the AP exam, and I just felt like that would be a lot of busy work. So right now, we're not going to be touching that. So anyway, if you want to grab some loose leaf and draw along with me, you can. This is your first review. I figured I'd make this pretty light. This is properties of water and hydrogen bonding. Okay. So first, we definitely need to draw a water molecule. So forgive me, I'm trying to draw on my laptop, which is not always the easiest thing to do. We know that in a water molecule, that water is H2O. So we've got two H's and a hydrogen. Okay, so there's our water molecule. So what do we want to talk about here? Let's talk about this bond first. Okay, that bond, when you see that solid line there, okay, that is going to represent, let me make my font a little smaller here. That is going to represent a covalent bond. Okay, and a covalent bond means the electrons are shared. Okay. Now, just like the way I taught this before, just like when you have to share something with maybe your brother or sister, that doesn't always mean that you share that object equally. So just because it's a covalent bond doesn't mean the electrons between oxygen and hydrogen are shared equally. So we've got two types of covalent bonds. Okay, you can have a polar covalent bond, or you can have a non-polar covalent bond. So you want to think of this as kind of like the two types of covalent bonds here. Okay, so which one is this? Well, what we know is we know that based on the trends on the periodic table that hopefully you learned about in a chemistry class somewhere, we know that oxygen is much more electronegative than hydrogen, which means that oxygen has a much stronger pull on the electrons in that bond than the hydrogen does. Okay, and part of that is because oxygen is larger. Okay, it's a larger atom. And so the bond that you see here is not only covalent, but it is polar covalent. Okay, and that's because if you think about those electrons being shared there, the oxygen is going to have a much stronger pull on those electrons than the hydrogen does. Okay, so the electrons are going to normally be found closer to the oxygen than they are to the hydrogen. So because of that, that is going to set up some partial charges. So let me see if I can get rid of that. So because oxygen has a stronger pull on those electrons compared to hydrogen, that is going to give oxygen a partial negative charge. Okay, it is not a full-blown negative charge. It's not an ion. Okay, and again, the reason it takes on a partial negative charge is because those electrons will end up being found closer to the oxygen than to the hydrogen. And so since the hydrogen is having those negative electrons pulled away from it, that is going to give hydrogen a partial positive charge. Okay, so this is a water molecule, one water molecule, showing polar covalent bonds, which are this line and that line, and then the partial charges on each of the atoms, okay? So why do we care? So we can think of this next slide. We'll say water's polarity leads to hydrogen bonding. Okay, so let's draw our initial water molecule. I'm going to turn it sideways this time. So there's a hydrogen. There's a hydrogen. All right, we said that the oxygen is going to have a partial negative charge, and the hydrogen will have a partial positive charge. So why does this matter? Well, remember that these atoms, because of these partial charges, are going to be able to hydrogen bond to other water molecules, okay? And so we're going to represent a hydrogen bond with a row of dots, okay? So this bond right here, shown as a row of dots, this is a hydrogen bond. Okay, so then we have to think about what atom would be over here, okay? Well, if the hydrogen's here and it has a partial positive charge, then I would expect an oxygen from a different water molecule to want to be attracted to that hydrogen. And again, that's because this hydrogen has a partial positive. This oxygen from a separate water molecule is going to have a partial negative, and then there's your hydrogen bond in there. Okay, same thing can happen here. All right, we can have another hydrogen bond here. Okay, and then here's another water molecule. And again, this would be the partial negative oxygen of that water molecule being attracted to the partial positive hydrogen of another water molecule. So over here, this oxygen, because of bond angles, this can actually hydrogen bond to two water molecules. So there's our oxygen, there's our hydrogen. This would be a partially positive hydrogen being attracted to that partially negative oxygen of our original water molecule. And then here is yet another water molecule. All right, this would be a partially positive hydrogen. So keep in mind that one water molecule, okay, can hydrogen bond to 4 other water molecules, okay? And let's talk about a few important things here. What do we want to talk about first? First, let's talk about the difference between liquid water and solid ice, okay? Keep in mind here that as you, I don't know if I can do that. As you let me find a different color. As you increase temp, you're going to increase particle movement. So think about, obviously ice is going to be in existence when it's very cold, when it's below freezing, okay? As the temperature warms up, okay, the particle movement, particles can move around more. And so what we're going to see as far as liquid water is we're going to see a lot of these hydrogen bonds being made and broken. So that's kind of what happens at warmer temps, is you have these bonds being made and broken. Whereas as the temperature decreases, so as temperatures get colder, so if we have decreasing temperatures, okay, you have less particle movement. And so that means that, that these hydrogen bonds stick around more. Okay, you don't have those bonds being made and then broken and made and then broken. They are going to stick around more, which is going to lead to that crystalline sort of nature of ice. Okay. Oh, what else? Well, we said that we were going to talk about properties of water here. So let's just think about this. Like I said, I'm not really trying to do a bunch of written notes. We've already done notes on these, and you should have them somewhere. I'm just trying to jog your memory and sort of talk through some things with you. So, properties of water. It has a high specific heat, okay, which essentially means that water can take on a good bit of heat before it causes a change in temperature. Okay, and that's important. We want our body temperature to stay fairly stable. And since our bodies are 2/3 water, it is quite important that the water in our bodies can take on a good bit of heat before causing a temperature change. Water also has a high heat of vaporization, which leads to evaporative cooling, which happens when you sweat. So when you sweat and we have that water on your skin going from a liquid form to a gaseous form, okay, it's taking the heat with it, which is what's cooling you down. Okay. We have things like cohesion. Cohesion is the attraction between the same kind of molecule. Okay, so let's think about that between two water molecules. Okay, and that can lead to surface tension, which allows things like bugs to walk on the water. You have adhesion, which is an attraction between two different kinds of molecules. So between water and maybe the sides of a graduated cylinder. And that's what causes that meniscus to form when you have water in a graduated cylinder. The sides kind of curve upward. And so that's the main thing for today. We won't always be this short. This one's only 13 minutes. I am going to post a Google Forms quiz. I'm trying to take some of the questions from the AP website. It's just that AP College Board website is a little bit hard to use right now. So I'm trying to take some sample questions from there and put them in a Google Forms quiz just so you have a little assessment to do after you've listened to the review. And of course, we're going to be reviewing all kinds of things in this next month. I can't review every single topic that we've done. You've got to do some of that. But we need to review enzymes. We need to review, gene expression. We need to review some with photosynthesis and cellular respiration, like the big idea topics. But we're going to be reviewing a lot of different topics in this next month. So I just need you to keep up with it. I'm not trying to give you a whole lot to do each day. You just got to listen to the review and do the assignment that goes along with it. Thanks so much. Bye-bye.